This is Biomechanics 6.3. Kinetics is the forces that are involved in movements. There are two kinetics, one being linear. This is when force, gravity, mass and weight is involved. The other is angular, and this is to do with levers in movement. Kinematics is the motion of an object or person. There are four different kinematics. The first being linear motion. This is where the motion is in a straight line and all going in the same direction. The next is curvilinear, is when the motion is in a curve. Angular motion is when the movement is rotational. The last motion is general. This is where the motion is linear and angular motions. Linear motion is all parts of a system that move in the same direction and at the same speed. An example of this is in the Winter Olympics where they do bobsleigh. Angular motion is when in a circular path around an axis with all parts moving through the same angle in the same direction and at the same time. An example of this is when a gymnast is on the high bars and spinning round the bars. The last motion is general motion. This is a combination of both linear and general motion. An example of this would be cycling. There are three ways of producing numerical models. The first way being literature-based. This is where information is found from journalists, websites and books. When you know the key numerical factors that you are interested in, you are then able to research the ideal values for them. The next numerical model is athlete-based models. This is where you either learn or compare your skill to another athlete's performance in something specific. For example, if you want to improve your serving in tennis, you would watch Andy Murray's serving and analyze why his serves are so successful. When doing this, it would ideally be comparing a more skilled athlete than the participant. The final numerical model is combination approach. This is where you use both of the other numerical models at the same time. So you use literature and observation to improve your skill. Vectors and scalars. Scalars is how big, far or fast something is and only has a magnitude. An example of this would be a basketball player running half of the court to score a dunk at 15 miles per hour. Vectors are how fast something is going in a certain direction that has a magnitude and a direction. An example of this would be a basketball player running half of the court to score a dunk at 15 miles per hour north. Speed and velocity. Speed is how quickly a body or object moves that is measured in meters per second. A sporting example of this would be LeBron James is travelling at a speed of 5 meters per second. Velocity is how quickly a body or object moves in a certain direction that is also measured in meters per second. A sporting example of this would be LeBron James is travelling at a speed of 5 meters per second west. Distance and displacement. Distance is the sum of all movements regardless of direction or the path it takes. An example of this would be a basketball is passed from player A to player B and the ball travels 10 meters. Whereas displacement is the difference between an object's beginning position and final position. An example of this would be player A passes the ball to player B and then player B passes it back to player A. The ball would then have a displacement of 0 meters. Example of both of these together would be player 1 passes the ball to player 5 and then player 5 passes it to player 3, where the ball is then eventually passed back to player 1. The ball would have then travelled 22 meters, but its displacement of the ball is 0 meters, as you can see in the photo above. Acceleration is the increase in speed or rate of an object or a person. Players in basketball need acceleration for when changing direction to attack or defend. An example of acceleration is player A passes the ball to player B where the ball accelerated at a speed of 5 meters per second. Another example of acceleration for a player would be a player tackles his opponent and then sprints to the end of the court to the hoop for a dunk and accelerates at a speed of 3 meters per second. Graph 1 shows acceleration. This is where the distance increased per unit of time. Graph 2 shows deceleration. This is where the distance decreases per unit of time. 3 shows stationary. This is where the motion's at the same distance over time. Graph 4 shows the same velocity. This is where motion at the same velocity is over the time of the motion. This is a velocity time graph, and it shows us where there is acceleration, stationary, and deceleration. An example of basketball to match this graph would be a player runs to receive the ball and then receives the ball and dribbles with it at the same speed, and then stops to play the ball and then decelerates back to its original speed. Stability is how stable someone is. This is useful for basketball players. They need to be able to keep balance during the whole game. An example of where this is needed is when a player is running with the ball. They need to be in full control of their body, as if an opponent tries to tackle them, they need to be able to change direction quickly so they keep possession of the ball. The centre of mass is the point at which the body is balanced in all directions, and this changes as you move. This is calculated by taking the mass you are trying to find the centre of mass between and multiplying them by their positions. Then you add these together and divide that by the sum of all the individual masses. There are 4 examples of the centre of masses in these photos. One of these examples is when a man is stationary, the centre of mass is between his chest and where his belly button is. The line of gravity is within the base of support. An object or person is thought to be stable. When the line of gravity falls outside the base of support, the object or person is then thought to be unstable. An example of this is when a person is stood stationary. Normally, the line of gravity is going straight through the middle of their body. The base of support is the area beneath an object or person that includes every point of contact that the object or person makes with the supporting surface. These points of contact being body parts or an object. An example of this is when a basketball player jumps up to score a dunk. The base of support is where they are stood off and leaping off. Newton's 3 laws. Newton's first law is inertia. This is where Newton believed every body resting or moving with a constant velocity in a straight line will carry this on and continue the same unless acted upon by an external force. For example, if a basketball is stationary, it will stay stationary until a force is acted upon it, like a player pushing it. Newton's second law is acceleration. This is where Newton believed that acceleration happens in the direction force acts on it. The equation to work out the acceleration of an object is force divided by mass. An example of this would be a player passes the basketball from stationary position to player B, then the ball will accelerate in the direction from player A to player B. Newton's third and final law is action and reaction. This is where Newton believed that for every action there is always an equal and opposite reaction to the object. For example, in basketball, when a player is dribbling the ball and in doing so bouncing it, when bouncing the ball on the floor, this is the action, and the reaction is the ball bouncing back up from the floor. There are 5 different things that force can do to an object. It can move an object from stationary to moving, so a basketball being passed from stationary to another player. It can also change the direction of an object. For example, a basketball getting thrown to a player and then a player intercepting it and changing the direction of the ball. It can make the object also accelerate and decelerate. When the ball is passed to a player, the ball then accelerates, but then when the player catches the ball, it then decelerates. And finally, it can change the shape of an object. When the ball is bounced on the floor, the basketball will then change shape from the force being applied down and up. Impulse is the change of momentum of an object when the object is acted upon by force for an interval of time. Impulse is calculated by force x time. An example of this in basketball is when throwing the ball. If you put more force behind it, it generates force for a longer time, or both together, then the ball will be thrown further. Momentum is the quantity of motion of a moving body, measured as the product of its mass and velocity, and is calculated by mass times velocity. An example of this in basketball is when you pass the ball east and the ball will have momentum going east. Shutter speed is the normal time for which a shutter is open at a given setting. The longer the shutter is open, the brighter the photo will come out. So if the shutter is open for a small duration, then the photo will come out how it is supposed to. Frame rate is the number of samples per second in a picture or film. When performing on a force plate, participants tend to change how they run as they are focusing on standing on the force plate correctly, so it affects the amount of force they would apply, so the data would then be incorrect. The lighting can also affect the capturing of the camera and can make the camera quality worse. 3D images gives us a more detailed image that can provide extra information about a specific athlete by the use of a wide range of different cameras that are surrounding the object. 2D images provides a basic image that only shows one perspective of the athlete or object, and this can then cause for missed information due to not being able to see everything. A school reference system can be defined by only two parameters: a point with a known elevation from which vertical differences are calculated. Imaging is electronic snapshots taken of a scene or scanned from a document such as a photograph. You can see an example here of where a person is taking a photograph of a basketball pitch here. Horizontal scaling is where in a video or photo an object or person can look bigger or smaller from the angle or distance from the camera. A way to prevent this from being mistaken is to have a well-known object for its size next to the person or object so that the viewers compare the sizes so they can make a rough estimate on the actual size of the person or an object. Here's an example where a person has a meter ruler up next against them so you can compare the sizes.